What does that mean? I've never been there. Does that mean they bring things to your table first?
Yeah.
And then you just choose off the table?
Yeah.
So once again, yeah, so the serve before the select and the serve and select are kind of mean slightly different things, maybe. How about at home? Your parents or grandparents or uncles or aunts. No pay, no select. You can bring your serve, right? Okay, so anyway, I think maybe there are actually, we can come up with a few other variants, but I think it's interesting to think at this level of abstraction, especially if you're interested in restaurants. If you were a restaurant designer and you said, hey, I want to build a new restaurant, one of the many things you have to choose or to think about and determine is how this sort of stuff is going to happen, right? Is this the whole picture of everything about a restaurant? What have we omitted in our model? Okay, so yeah, that's a good point. Everything that happens before the customer comes in. A situation, I'm sure, where there's been within your debate or question about where am I going to eat, where are we going to go, oh, this one's full, oh, there's always a long line. You know, so there's a whole sort of discussion of which restaurant that comes first. That's an important phase. At a restaurant, at Schmidt's, is it really select, serve, eat, pay? Or could we put select, serve, eat in a loop? Select your drink, it's served, you eat it, or drink, it's consumed. Select your main meal, serve, eat, select your dessert, serve, eat, pay at the end. Is that right? I haven't eaten in Schmidt's in 20 years. But anyway, that's sort of the sit-down restaurant norm in the United States. In other countries, it's different too. But, so first of all, we might, in sort of thinking about modeling the process of going to a restaurant, we might include completely other things like how do you choose what restaurant. We might want to have some notion of iteration, repeats. Do we want to think about the food? You can answer yes or no. We might. It depends entirely on what our goal is. It's a model. A model is not supposed to do anything. You can't criticize a model for leaving things out. That's the whole reason we have models, is to leave things out, okay? So, my point of bringing this up is not because this is in for Restaurants 43, but because I wanted to sort of get you thinking in terms of a process that actually happens. You actually go to the restaurant, you actually go through these things, and you've all done that, I imagine, many times. And then there's a model of it where we say, we abstract away what you ordered, or whether the waiter was nice to you, or whether you're on a diet, or all these sorts of things that are actually important things. And we just say, oh, we're only going to focus on these 4. And of course, I can say, focus on these 5, or these 3. I mean, we can, there's nothing to these 4. But it's an abstraction. That's what abstraction is. It's removing details. That's what modeling is. Okay? So as we talk about abstracting the process of building software, it's going to be harder for you to think about that because you've been to probably all of these types of restaurants multiple times. So you really have a lot of actual personal knowledge that you can draw on. You probably, most of you, have certainly not developed lots of software systems multiple times. To be able to draw on that personal knowledge, you're going to have to sort of use your imagination and sort of start from the theory and go and imagine the practice rather than starting from the practice, and then I tell you the theory of software process, restaurant process models. Okay, so with that little introductory notion, let's look at a few process models. And we've already talked about the waterfall, and we'll come back to that. But here's an interesting process model, which is sort of, if you were a programmer and all you thought about was programming, this is probably, someone said, well, how do you actually get software made? You'd say, well, someone tells me what to do. That's the problem statement. This is actually, maybe we could call this the first-year computer science programming course process model. So, you know, Norm Jacobson or David Kay or Alex Thornton tells you here's what you have to do for homework too. And so that's, and it's in a circle, and there's a dotted line. I don't know what the dotted line means here. and then you code it, and then you compile it, and if there are problems, like you left off a semicolon or something, then you go back and you debug it and you code some more. And then once it compiles, you need to test it, and this is called unit test because there's a notion in testing of testing one unit, one small little section of code, maybe one method, one routine, one file, whatever, however your programming language creates units, one class. That's a unit test. It's a small test. So you run some tests, or it's a test of a small amount of code. You run some tests, probably there are problems, and so you debug and you go through this cycle a few times, and then you're done. Your software passes all the tests, and you release it. And release may mean you send it to a customer, or in first year computer science, it probably means you upload it to Checkmate, or something like that, right? You're released. Your bonds have been snapped. Seem reasonable? So nothing wrong with this model. I mean, this actually does capture some important aspects of developing software, but it's very focused on the programming. And programming is very important, but there is a lot more, and hopefully maybe the major underlying theme of this course is software development is not just programming. So, we can have the waterfall software process model. This is a slightly different picture than the one you saw before, but it's got that same downward slope characteristic. Requirements, design, code, test, and then integrate and package. So integrate and package can mean different things, but you may need to integrate your software with other people's software, or with, you may have different people working on things that needs to all fit together. That's the integrate step. And then package means somehow you have to release it. You have to burn it to a CD, or put it in a certain folder, or send it to the App Store, or whatever happens to sort of package it up into something that someone else can run without you, the developer, being there. That's the package stage. Okay? So we talked about that before. The waterfall model is wonderful in that it's sort of the ideal situation. If we didn't have humans involved, this is how it would look. We would be able to figure out the requirements, and they would never change as we did design, coding, and testing. The reality is not that simple, but it's an idealization. It's linear, it's rigid, it's unrealistic, but it's sort of a goal to shoot for. Yeah.
The waterfall model seems kind of counterintuitive. With coding and testing and having it failing completely, that it would be better to go back to the review the requirements and then go back to the design phase and try and figure out a different step instead of wasting more time on coding and testing. So what's the interaction there with the iteration?
Okay, so it's a good point. This seems contradictory. The observation is that the waterfall model is contradictory to an iterative approach. And that's absolutely true. There is no iteration from phase to phase. The waterfall model says once you get to design, you never go back to requirements. Once you get to code, you never go back to design. Within one of these phases, there can be iteration. So how does the requirements box, what's inside that requirements box? Well, the waterfall model doesn't say, but it would be okay to have an iterative approach where you, the software developers, meet with your client, you write down what they want, document, they say that's okay, but not this and more of that, and that process continues back and forth for a week or a month or whatever it takes. And say, okay, we're done, and the user signs off, and now you can say, now we can begin design, and we will never go back and review those requirements again. That's the model. Is that actually whatever happens? No, but it's the model. It's not a completely realistic model, but let me give you another example of models that are nice models but are not completely realistic. Hopefully this won't be too embarrassing. Have any of you ever asked your grandmother or grandfather, let's say your grandmother, how did you meet Grandpa? You should, if they're alive, do it. No one ever hardly anyone does not want to talk about that. probably say we met over the internet or something like that. But, no, probably. That's how your grandparents will, your grandchildren, what you'll have to say to them. Probably your grandmother will say something like, we met at a dance, we danced, we started dating, he asked me to marry him, we got married, and 45 years later, there you are. You're in college, it's so great. In other words, it's a linear model. It's an idealization. Now, think of your own romantic life. Probably most of you are not married, but think of your own romantic life and those of people you know and your siblings and stuff like that. Is it a linear process? You meet someone at a dance, you start dating, you fall in love, marriage? No, it's not. I mean, every once in a while it is, and that's great. But for the most, this is leaving out all sorts of stuff. This is leaving out confusion, and oh, he asked me out, but I like him better, and she's the one for me, or I like her because of her hair, and I like her because of her shoes, or whatever guys like these days. I'm dating two people at the same time, and what if they find out, and I'm heartbroken, and all that kind of stuff, right? I'm getting some glimmers of recognition that these things happen. And certainly, when I was in college, these things happened. I suspect they still do. So the actual reality, the actual process is confusing and emotional and not at all linear. But I am sure that 50 years from now, when your grandchildren are going to the University of California, Newport Beach, because we've moved over there, and they say, Grandma or Grandpa, you went to a precursor institution. How did you marry, what's her name? Grandma, how did you marry Grandpa? You won't say, well, I saw him at the dance, but I was dating someone else at the same time. I had to go to him. You won't say all that sort of stuff, right? You'll make it very linear. So that's what I mean by the waterfall model is like this ideal, if everything was perfect, if there wasn't any confusion, this is what it would solve. Software like in reality. But it's still a useful model to have. Just like it's useful to have the romance model of eyes meeting across a smoky room, first dance, falling in love, married, later, 9 months, 3 hours later, however long it takes. And no one's saying that never happens, but it certainly is not the usual. But it's still this ideal in our society. It's this ideal that we want to. Maybe after the fact, we want to be able to focus on the really important things. And we say, oh, it seemed at the time I was so confused which person to date. But once you choose correctly, it becomes very clear. It's sort of like a Jane Austen novel. At the end, like Jane Austen novel, you know who she should have picked, right? But halfway through, you don't.